the Arizona Signal Watcher DXing video blog, episode 14, a 5-element Yagi for FM broadcast band. So this new FM broadcast band antenna that I've built to use for sporadic-E openings during the late spring and early summer comes from Brian Beasley's webpage at ham-radio.com K6STI index.html. And he has models here for lots of different antennas, including many commercial antennas, including the very popular Antennacraft FM6 antenna, which is discontinued. Some of these antennas aren't sold anymore. But he also includes some self-designed antennas. And so what I have built is the small 5-element Yagi. So take a look here. This is the scale drawing of the design. Note that it has an angled driven element, which is one of the ways which you can get good performance out of 5 elements without having a say multiple elements phased together. Turns out that by angling the element like this, that helps the pattern. This antenna is a little bit shorter than the FM6, and so the gives the modeling results here. And here's the list, the forward gain, and this is gain dBd, so decibels of gain relative to a dipole. So add 2.13 for dBi, decibels over isotropic. So it ranges from about 5 to 7 across the FM band, so that's a pretty good figure for 5 elements. The SWR is very good over the whole band. And the front to back ratio is consistently right around 20 to 22 decibels. And so those are good performance numbers for a small antenna. Now here's a plot where he shows comparisons. The red here is this particular antenna. The blue is a similar model. And then the dimensions that he gives. Now these dimensions are in inches, and these are half lengths. So for instance, the driven element here, 29.5168 inches, that's the half length, and the others are half lengths as well. This 20.388, that is the angle for the driven elements, so that's how much they're angled back by that 20 degrees. And then it gives the distances along the boom, so 17.95 inches up to 63.7 inches up for the front driven element. So that's the antenna that I built. So now I'm going to show you how I built this. Okay, so what I have here is a 6-foot poplar board. It's 3.5 inches across and 3/4 inches in height. And I've put several coats of polyurethane on it. You can see the shiny finish. I don't want to necessarily say this is truly waterproof, but at least very water resistant. And here, pardon the glare, these are my 6-foot sections of 3/8 inch aluminum tubing. Pick those up from DX Engineering, and we'll cut those down to size. And then to attach these elements to the board, I have these resin support blocks. So this goes across here, and you can attach that really tightly. And then this goes onto the board. Now of course it's going to go like this, and I'm going to put 2 of these for each element. That'll help keep it straight and give it a little more support. And these things, a pair of these in the 3/8 inch size and also in the 1/2 inch size, only $3.49. So relatively speaking, not too expensive. If you are on a really small budget, of course, you can replace this poplar with pine, which is a little less expensive, and also only maybe use 1 of these clamps for each element. Also, you might be able to find, recycle some kind of old antenna, maybe an old TV antenna that you find, something like that. The main thing is that that you need these to be the proper length. So what we've got to do is mark the board so that to get the proper distances, and then drill the holes for the first clamp, and then based on that we'll use that as a reference to make sure to get the second one. And we want to have a little bit of wiggle room in these so that the you can move things ever so slightly to get these as perpendicular to the board as you can. Now the one tricky one is going to be for the driven element. Now that one we're not going to have room to use two pairs of these because we have to put it at an angle. So it's going to look something like this, and there just isn't room for another support. So we'll have to be particularly careful there. What I'm going to do is I'll put this as close to the edge as possible, and this will hang. This will kind of come through a little bit up to about, so that they're only about maybe 1/4 or 3/8 of an inch apart, the two driven elements. All right, so what I've done here is there's the line for the the reflector element, and I've drilled 1/4 inch holes through here. And let me adjust my light here. I'm using a little bit better lighting here. This is too big for my project table, so I'm on the kitchen peninsula. Okay, so what I've got here, I've got my nylon hex screws. Whoops, and didn't want to do that. Try that again. There we go. Okay, so that is the first draft here of how this is going to fit. Now I want to make sure this is centered as well as possible. What I will do is grab my square, and I will set this maybe I'll set this here. You'll have to excuse my finger. That was unrelated to this project. I cut myself with an X-Acto knife, and it's one of those cuts it doesn't want to stay. It's healing, but it doesn't want to stay closed very well. So I got to tape it up in case I bump it or anything. Okay, so now what I want to do is I want to make sure this is at here at 3/4. Now it won't be exactly centered in these blocks because I didn't get the blocks exactly the same position on a mirror image, but that's okay because what's important is where the elements are relative to each other. Okay, so I've got that. Now, so what I can do is, well, I need to make sure this is the element here is perpendicular to the board, and one way we can do that is with the square. And notice that this was ever so slightly off, which is, remember that there's wiggle room here. That's the whole point. It's not that it's off, it's just that there's a little wiggle room. So let me go ahead and with that drill that hole. Okay. Alright, so let's see how that looks. I'm going to put a screw in it. Okay, that's pretty tight. That's okay. As long as it goes in. Okay, now let me center this back up. What I'm going to do here, let me
do it this way. Okay, so there is centered pretty well. Now for perpendicular though, I got to be careful. Now this is going to have to push a little bit there. Okay, so now for this one, I'm going to use my punch. And then I'm going to drill that hole with that taken out. Slide my sacrificial board under here. Okay. Now let's go ahead and put this back under and put that in. Okay, so now again, oops, I had that there just for glare and then I just knocked it over. Okay, so let's put this back on here. Alright, now there's going to be, there's the 7. Okay, and let's put this in here. Okay, make sure that's still pretty well centered. Okay, now it's got to push a little bit there, but that's all right. So what I'm going to do now is go ahead and start putting on the wing nuts. And these are almost too close together to use the wing nuts, but not quite. Okay, so alright, so now I've got that kind of battened down. That still can move a little bit. Okay, so it needs to move just a little. Okay, but that's pretty good otherwise. Alright, go ahead and put one wing nut under here. Now these are 2-inch screws, so there's just enough room on the other end. We'll see that in a moment. There's just enough room on the other end for a that the nuts will hold. Okay, now let's do this. Okay, so those are getting tighter. Okay, so what I want to do is hold those underneath with my fingers and tighten these. Looks pretty good. And that looks pretty good. Now let's go ahead and tighten these. Okay, so we're getting these pretty tight now. This is not free to move much. Let's do one more check here on square. That's going to be pretty good. Now, you may not get this perfect, and you know, it doesn't have to be perfect. You just want it to be as good as possible, though. So it's good to, you know, so if you're working with simple tools and everything, that's fine. Just make sure you check your work often as you're doing this. The clamps there, if you just set them on top there, there's a little bit of a gap there between the two halves. But if you screw it down tight, then it deforms ever so slightly by, you know, a 32nd of an inch or whatever, and that gets it nice flat and level. So you just want to make sure these are all as tight as you can get them. So that is the reflector element, and so now we just have to do this for 3 more straight elements, and then we'll work on the bent element, the driven element. Okay, so what I've done here, I've finished. I've got all the other 4 elements in place, and now I need to do the bent element. And so again, I apologize for the glare here. I've used a square here to draw a line across at the right distance. That's where this is the plane of the feed point, if you will. And then with the protractor, I've drawn lines here at basically a 20-degree angle. The exact angle is 20.4 degrees, but that will be adjusted at the other end of the element by how close it is to the reflector element. And so again, we'll put down these the clamps here and line it up along here, but we'll only put in 1 screw here until we get it just right, and then we'll screw down the other side. Okay, so to get the angle of the driven element correct, we're going to take the advice of the website there, and what we want is the center of the 2 elements here to be 7 11/16 inches apart. So that's going to be about right here. So here's what I'm going to do for the feed point connection. I'm going to take some of this 1/4 inch copper tubing, which fits right into this. This is by design. The tubing here is designed to fit inside the next larger size, and this is 3/8 inch, so 1/4 inch goes in here, and push that in as far as it'll go. Make sure there's a good connection, and then this little lip will hang off, and then I can solder a wire, and that wire will go through the board, and the main thing is that this gives me something that I can solder, and still should have a good connection here to the actual element. Okay, and for reference, here are the ends of the 2 driven elements prepared. There's the copper tubing wedged in there and folded over, and then I have soldered some solid wire to that, and that wire will go through holes in the board, and that'll connect to the BNC socket, and then these will be trimmed to however long they need to be. Okay, and here is the final feed point assembly. You want to try to keep this about 1/8 or 1/4 inch apart at the feed point, and then I have wires that run down and underneath, and those will hook up to the BNC socket, so that'll be mounted like that underneath here. Okay, so to attach this to a mast, what I've done here is I've taken this scrap piece of 4x4 and drilled a 1 1/4 inch hole with a Forstner bit, and that will hold a piece of 1 inch mast, and or you can adjust that to whatever size of pipe, PVC pipe or whatever. And then in the center of that I've drilled a 3/16 inch hole, and I continued that hole through the beam. And so the main attachment for this piece to the beam is going to be a 3/8/16 bolt. And then the mast, a piece of mast will go in here. It'll be maybe a foot or a little more than a foot long. And then that mast will slide into the next larger size mast at the top of my antenna mast assembly. And with that in place, we can go ahead and drill 2 more holes for 2 more 3/16 bolts to go through there, and that'll secure it very well. Now with this section of mast in place, then we're going to drill a hole through the side of that block and through the mast and out the other side, and put another bolt through that. So what I'm going to do here at the feed point, I decided to use a little project box here, and I've drilled a 1/4 inch hole here to attach this to the beam with a 1/4 inch nylon hardware, and I've drilled 2 holes in here to route the feed wires into that. And then on the lid I'm going to mount the BNC jack, and that way that'll give that support. Okay, so here's the inside of the lid of the box. There's the back end of the BNC socket, and I've used these those long hex nuts. And there's the BNC socket, and so now I just have to run the wires through here and connect those to the back end of the socket here. Okay, so it turned out my connector wires weren't long enough to do this, so I put some jumper wires on there, so I soldered those on, and then they're connected here on the inside, which you can't really see, to the back end of the socket. And so if we push those down, and there we go. Okay, so here's the fully assembled antenna. So this is the top side. And here is the bottom side. And that includes the post that goes into the top of the mast. Now, one thing about a receiving antenna is that you don't have to worry about being in proximity to it. And in fact, especially during the Arizona monsoon, I actually set up this antenna indoors. Now that has a couple benefits. Number one, it means I don't have to unhook during a storm. So if we get a thunderstorm in the middle of a nice sporadic-E opening, I don't have to worry about that. Also, it means I don't have to use a rotor, and this is an antenna that is going to be put up and taken down. It's hard for me to have any kind of permanent antennas up, especially if I also want to have antennas for ham radio. So I can just use my old Armstrong rotor and rotate this as I'm monitoring. And it also means that I can use a much shorter feed line. So in this case, it's only an 8-foot feed line. Now, it's hard to show live DXing with this because you'd probably have issues, if you're listening to a station that's playing music, waiting for the song to end so you hear the DJ say something. Well, you can't really do that on YouTube so much. So what I'm going to show you here, this is normal conditions. This is with the antenna pointing kind of east-northeast, which is a typical direction. Keep in mind that since I'm in Arizona,
and the skip distances for FM are generally about 500 miles or more. Basically, I'm working from southeast around through east, northeast, north, and northwest. And so with this antenna being on the northeast side of the house, there's just either the ceiling or the walls, but not multiple walls coming through, so still get a pretty good signal. And so this is pretty typical conditions. Now what I'm going to show you next is an example of what this can look like when there is a lot of sporadic-E activity. Now that should look quite a bit different. This is basically pointing exactly. You can see the nice continuity here of my local stations. So this is basically identical to when I recorded this, except all of these additional stations are in. In fact, there's basically stations on every frequency. I have, probably, I'd say close to 60 good frequencies out of 100 on FM for sporadic-E. Sometimes there may be something weak on there, but any kind of decent sporadic-E can override that. There are another 20 frequencies where I've also picked up sporadic-E that's come over a weak local station. There's about 10 more that I think can be overcome with the right combination of direction, so the antenna is nulling out a local station and having a good strong distance station in that. And then there's about 10 frequencies, the really obvious ones you can see on here, that will be very difficult to get sporadic-E because the local is strong, and because it's so strong with reflections off of the house and the mountains and everything else around here, it's hard to completely null out the station just by rotating the antenna.
This is South Dakota Public Broadcasting. From the campus of the University of South Dakota, this is KUSD-FM Vermilion at 89.7.
And you are listening to Minnesota Morning on KMS Radio, 89.7 FM in Mankato, and KMSK 91.3 FM in Austin, online at kmsu.org.
Now, you heard that. Now, that was a really nice one because we had South Dakota Public Radio first, KUSD, and then we got a Minnesota station. And that's a classic example of two fairly strong signals swapping. And because of the capture effect on FM, basically as soon as one signal gets a little bit larger, stronger than the other, the demodulator locks in on it and more or less completely shuts out the other one. And so there was a case of getting logging two stations in one shot. But this just demonstrates that on this particular day, this was actually taken on July 23rd, which was the best opening this year so far anyway. And there was activity all the way up to the top of the FM band. So basically the other half of the FM band, this is pretty much the low half, would have looked the same. So in any case, this antenna works at least as well as my FM6 commercial antenna. So this antenna does have some small advantages over the FM6. It's a little bit smaller. It doesn't have as many mechanical connections, so perhaps that makes it a little more robust in that regard. It's a simpler design, which means it's easier to do any modifications and such. And of course, it's you build it yourself, so that's kind of a nice thing. And finally, the FM6 is not made anymore. And so if you're just getting into FM broadcast band DXing, you'll either try to find a used FM6 or some other FM antenna, or build your own. And if you're looking for a compact antenna, this 5-element design should work pretty well.